So back into arena view, here we have round 11. We're seeing a lot more scoring going on now. A lot of activity, so many different challenges being scored on. We're seeing POVs being thrown from in every color. So every team is actively throwing POVs again.
And now just because we see a thrown POV doesn't necessarily mean it's a successful POV, right? So you could be throwing a POV that is just not actually succeeding.
Yeah, there's a couple of clues. We got to look for when the points go streaming back to the original, and then we can look here and see, after they've started tallying up, who has each team scored against. One thing that's really interesting here is we have Mayhem. Now we know Mayhem is in first, and if you want to wonder why, you can look at how many challenges they are scoring on. 6 different challenges Mayhem is actively scoring on right now. And 3 of these challenges, see if I can get them here. These 3 challenges, if you look across the board, nobody else is scoring on those 3 challenges. That means Mayhem has found the bug and crafted a working POV for 3 different binaries that no other team has been able to do. And 2 of them are actually heap exploits. So these are heap buffer overflows that Mayhem is exploiting in these challenges. And heap bugs aren't the easiest ones to exploit.
Heap is tricky, right? So we've talked a lot about so far about buffer overflows and mostly stack-based buffer overflows where you're overwriting either a return address or you could, of course, write some other variable or something else on the stack. But the heap is hard, right? Because it's not this sort of linear kind of memory layout, but you have to control allocations, and that's what makes it tricky. So it's a little bit kind of like arranging boxes of various shapes and sizes. And so even if you can cause an overflow from one allocation to the next, trying to get them lined up in such a way that everything fits and that you can sort of call your shot and control something useful and interesting is not easy. You might be able to kind of get lucky into it, but usually it requires significant sort of intentional manipulation. So that's a really big bar for them to have hurdled, and to not have just 1, but 2. The other part about this I think that's fascinating is that these heaps are not standard heaps, right? Because everyone had to implement their own libc, their own allocators. That means this is not,
a
any of the standard malloc
implementation,
right, that are out there. And so they had to have some sort of generic ability to detect this is an allocator, this is a free, and then model that. That's pretty cool to be able to successfully use that in a POV.
So Mayhem was written by For All Secure. For All Secure is a small cybersecurity company, but they have their roots in Carnegie Mellon.
For All Secure was founded several years ago from my grad students at CMU who really, I said, let's go work on automated exploit generation. And they went from this abstract idea to a working prototype. And we've grown by hiring more CMU students who are really into this hacker culture.
Carnegie Mellon with Plaid CTF, PPP.
Oh, the Plaid Parliament
Plaid
of
Parliament
Pwning.
of Pwning, yeah. They're one of the sort of rock star teams of the CTF community. They've been around for many years and have done very, very well, often many years leading the sort of this top scoring system in the CTF community. So it's not a surprise that they get CTF. And of course the research that comes out of Carnegie Mellon and Dr. Brumley, their lead, it's not a surprise that as he founded the company, that the company has this sort of strong academic but also practical CTF. They've got a lot of the right ingredients certainly to do well.
Well, we'll see if they can keep it up throughout the whole game.